Welcome to the Week 6 spreadsheet beta in the security market line. In this video, in this movie, I'm going to show you the solution to problems 1 to 4. In essence, what we're going to be testing in this movie is that the S&P 500, which we can see here, represents a genuine market portfolio. And the way we're going to do that is we're going to see whether our estimates of betas with respect to the S&P 500 are in fact provide a good explanatory model of the returns. So, let's break that down now. Here what you can see in yellow is the first problem. And remember, please put your name and your email address here in cells B1 and B2. So once you've done that, you need to calculate the mean. The mean is easy to do. Mean of AMR is the average. Beta 1 and beta 2 are two different ways of calculating the beta. First, you can use the covariance divided by the variance. So that's the covariance of the assets of AMR with the market, which we consider to be the S&P 500, divided by the variance of the market. An alternative but equivalent way of calculating the beta is to use the slope command. The slope command calculates the regression between, or estimates the regression between AMR and S&P 500, and then returns the slope or the gradient of that linear regression line. Okay, it's a sensitivity between the stock AMR and the market S&P 500, and it should be identical to the beta 1 calculation, and in this case, of course, it is. So let's now move to problem 2. And in problem 2, what we do is we now relate or estimate a regression trying to relate the mean returns of each of these stocks to their betas here. And if the security market line tells us that there should be a perfect relationship between the two, let's try and confirm that now. Well, what we do is we find the intercept, and this is the alpha or the intercept in the linear regression line. We find the slope using the slope command again, but now it's the slope between the returns and the betas, and we find it's 0.054. And then we find the R squared, and this is really the key. The R squared is a number which varies between 0 and 1. And it gives us a feeling, or it tells us how much of the variability in the data the linear regression can explain. An R squared of 1 tells us that the linear regression can explain all of the variability between the independent and the dependent variable, in this case between the mean and which is the mean return, which is the dependent variable, and the beta, which is the independent variable, the explanatory variable. Unfortunately, we can see that the R squared is only about 28%. So 72% of the variability in the data is not explained by beta, not explained by the explanatory variable. And that points to a problem. We're going to hypothesize that the problem is that our market portfolio, the S&P 500, is in fact not an appropriate market portfolio. We believe that it is not on the efficient frontier. And we're going to confirm that in the problem 2, part method 2, and so on. Now I'm going to go over this very, very quickly. What I'm going to show you is how to calculate in problems 3 and 4. You're going to recalculate the envelope portfolios X and Y using the methodology that I showed you last week. And I'm not going to go into much detail in that for you this week. Look back to last week for that. Steps 1, Steps 2, and Steps 3 are identical to last week, except now we have a constant of 0 and a constant of 0.1. And in Step 3, we have a 2-asset portfolio, which is the combination of portfolio X and portfolio Y. And we have the calculations of the variance, the standard deviation, and the covariance, just like last week. In Step 4, we combine using cell D100 as a proportion of X in the portfolio, and 1 minus the cell as a proportion of Y. And we use a data table, which you don't have to do, to construct all of this here. Okay. What's key though here, and we'll use this in the next problem, in the next video, in the next movie, is that we increment the proportion of X in steps of 0.1, and what's in the pink box here. So we go from -2 to -0.19 to -1.8, etc., etc., etc. And that'll become important in the next movie. Okay? Well, that's it for problems 1 to 5. Stay tuned for problem 1 to 4, I beg your pardon. Stay tuned for problem 5 in the next movie. Thank you.